Welcome back. This is the first video in our long series on the implementation of compilers. Recall from last time that a compiler has 5 phases. We're going to begin by talking about lexical analysis, and this will probably take us 3 or 4 videos to get through at least, and then we'll be moving on in order to the other phases. Let's start by looking at a small code fragment. The goal of lexical analysis is to divide this piece of code up into its lexical units. So things like the keyword if, the variable names I and j, and the relational operator double equals, and so on. Now, as a human being, this is as we discussed last time, this is a very easy thing to do because there's all kinds of visual clues about where the units lie, where the boundaries between the different units lie. But a program, a lexical analyzer, doesn't have that kind of luxury. In fact, what the lexical analyzer will see is something that looks more like this. So here I've written the code out just as a string with all the white space symbols included. And it's from this representation, just as a linear string, you can think of this as bytes in a file, that the lexical analyzer has to work. And it's going to march through placing dividers between the different units. So it'll recognize that there's a division there between the white space and the keyword, then a division after the keyword, and some more white space, the open paren, the I, another white space, double equals, and so on. And it goes through drawing these lines, dividing up the string into its lexical units. And I won't finish the whole thing, but you should get the idea. Now, it doesn't just place these dividers in the string, however. It doesn't just recognize these substrings. It also needs to classify the different elements of the string according to their role. And we call these token classes, or sometimes I'll just call it the class of the token. And in English, these roles are things like noun, verb, adjective. Okay, and there are many more, or at least there are some more. And in a programming language, the classes, the token classes would be things like identifiers, keywords, and then individual pieces of syntax like an open paren or a closed paren. Those would be classes by themselves. Numbers. And again, there are more classes, but there's a fixed set of classes, and each one of these corresponds to some set of strings that could appear in a program. So token classes correspond to sets of strings, and these sets of strings can be described relatively straightforwardly. So for example, the token class of identifiers in most programming languages might be something like strings of letters or digits starting with a letter. So for example, a variable name or an identifier could be something like A1, or it could be foo, or it could be B17. All of those would be valid identifiers. And often there'll be additional characters that are allowed in identifiers, but that's the basic idea. Very, very often, the main restriction identifier is that they have to start with a letter. An integer, then, typical definition of an integer is a non-empty string of digits. So something like 0 or 12, okay, 1 followed by 2, I should say, is actually a string, not a number in this case. And you know, this actually would admit some numbers you might not think of. Things like 001 would be a valid representation of a number, or even 00 could be a valid integer according to this definition. Keywords are typically just a fixed set of reserved words, and so here I've listed a few: else, if, begin, and so on. And then white space is itself a token class. So we actually have to say in that string, which is the representation of the program, what every character in that string, what token or what token class it's a part of, what every substring is a part of, and that includes the white space. So for example, if we have a series of 3 blanks, if I say if and then an open paren and I have 3 blanks in here, these 3 blanks would be grouped together as white space. So the goal of lexical analysis is to classify substrings of the program according to their role. This is the token class. Okay, is it a keyword, a variable, an identifier? And then to communicate these tokens to the parser. So drawing a picture here, let's switch colors. The lexical analyzer communicates with the parser. Okay, and the functionality here is that the lexical analyzer takes in a string, typically stored in a file, so just a sequence of bytes, and then what it sends to the parser is a sequence of pairs, which are the token class and substring, which I'll just say string here, which is so it sends a string, which is a part of the input, along with the class, the role that it plays in the language, and this pair together is called a token. All right, and so for example, if my string is that foo equals 42, all right, then that will go through the lexical analyzer and out will come, I'll write it down here, 3 tokens, and these would be identifier, foo, operator, say, equals, and integer, 42. And here I've just left these things as strings to emphasize that these are strings. So this is not the number 42 at this point in time. It's the string 42, which is plays an integer role in the programming language. And then what the parser takes as input is this sequence of pairs. So the lexical analyzer essentially runs over the input string and chunks it up into this sequence of pairs where each pair is a token class and a substring of the original input. Let's return to the example from the beginning of the video. Here it is written out as a string. And our goal now is to lexically analyze this fragment of code. We want to go through and identify the substrings that are tokens and also their token classes. So to do this, we're going to need some token classes. So let's give ourselves some of those to work with. We'll need white space. And so this is sequences of blanks, new lines, tabs, things like that. We'll need keywords. Okay. And we'll need variables, which we'll call identifiers. And we'll need integers, and I'll call those numbers here. And then we're going to have some other operations, some other classes, things like open paren, close paren, and semicolon. And these are interesting. These 3 are interesting because they're single character token classes. That is, it's a set of strings, but there's only one string in the set. So the open paren corresponds to exactly the set of strings that contain only open paren. So often the punctuation marks of the language are in token classes all by themselves. Another piece of punctuation that we'll add here is assignment. That'll be in a token class by itself because it's such an important operation. But the double equals will class as a relational operator. We'll just class it as an operator, put it up here. All right, so now what we're going to do is we're going to go through and tokenize this string, and I'm going to write down for each substring what class it is in, and I'm just going to use the first letter here of the class to indicate it, just to save time so I don't have to write everything out. And let me change colors so we can do this in a different color. So the first token here is a white space token, and that followed by the if keyword, so K. And then we have a blank here, which is another white space. And then the open paren, which is its own token class, so I'll just leave it to identify itself there. And then we have an identifier, okay, white space, and then an operator, the double equals. another blank, so that's white space, followed by another identifier, followed by close paren. So again, a punctuation mark in a token class by itself. And then we have 3 white space characters, so those are grouped together as a white space token, followed by another identifier and more white space, and then another single character token, the assignment operator, white space, and a number. All right, and then semicolon again, a punctuation mark in a token class by itself. 2 white space characters get grouped together. What follows then is a keyword, so that gets classified as in the keyword token class. Another run of white space characters, and then another identifier. There's actually a blank there, although we almost covered it up with our marks. The assignment operator by itself in a token class, white space, a number, and finally the semicolon by itself. And there is our tokenization. We've identified the substrings, and we've also labeled each one with its token class. To summarize, lexical analysis implementation has to do 2 things. The first job is to recognize the substrings in the input that correspond to tokens. And here's a little bit of compiler lingo. These substrings are called the lexemes. So the words of the program are called the lexemes. And then the second job is that for each lexeme, we have to identify its token class. And then the output of the lexical analyzer is a series of pairs, which are the token class and lexeme. Okay, and this whole thing, one of these pairs, is called a token.